Here is the answer for day 3, problem 1. Find the inverse of the given matrix. A square matrix can have an inverse, and this is a square matrix. Let's say that this is matrix A. To find the inverse of matrix A, there is a technique to follow. It's 1 over the determinant of matrix A times, and then there's a certain pattern that you follow with what to do with these entries. If this was A, this was B, and this was C, and this was D, then what you do is you switch the positions of the A and the D, and you change the signs of the B and the C. Let's follow this technique with our matrix. So we see that we need to know the determinant. So let's figure out what that determinant is. It's 3 times 9, which is 27, minus 8 times 6, which is 48. This makes negative 21. So to get our inverse, we have 1 over negative 21 multiplied to a 2 by 2 matrix. We want to switch the positions of the 3 and the 9. And we want to change the signs on the 8 and the 6. Now multiply that scalar to each entry in the matrix. Negative 121 times 9 is negative 9 over 21. Negative 1 over 21 times negative 6 is 6 over 21. Negative 1 over 21 times negative 8 is 8 over 21. And negative 1 over 21 times 3 is negative 3 over 21. A lot of these fractions are reducible, so let's reduce them. This makes negative 3/7. This makes 2/7. Down here is 8 over 21. And then over here in the bottom corner is negative 1 over 7. Day 3, problem 2. Explain why the matrix has no inverse. This is a square matrix, and a square matrix can have an inverse, and we saw the formula that you follow for how to find that inverse. Notice that part of the formula involves the determinant in the denominator of a fraction. We know that you cannot divide by 0, so if the determinant is 0, then there can be no matrix. Let's find the determinant of this matrix. 5 times 6 is 30, minus 2 times 15, which is 30, and that's 0. So it has no inverse because the determinant is 0.